All right, so let's now talk about the distribution of my sample proportion. All right, so in this, a bag contains 8 blue balls and 4 red balls. If we take a random sample of size 4, what is the probability that there are 2 balls in the sample, 2 blue balls in the sample? In other words, p hat is a half. So let's think about if we're counting the number of number of blue balls. So the sample proportion p, I have 8 out of 12, which is 2/3. Yeah, so that's the population proportion. So what I'm interested in is the sample proportion p hat being equal to a half, all right, which is the same as 2 balls. So if we work out our probabilities now, so to work out, so what's the probability? Let's work out the probability that x is equal to 0. Now that means that of my 4 balls that I pick, okay, so of the 8 blue balls, I'm going to pick 0, which means of the 4 red balls, I'm going to pick 4 out of, well, how many balls am I picking in total? Well, I've got 12 balls to pick. I'm going to pick 4. Okay, so the top line there is just how many ways I can pick 0 blue balls. And the bottom line is how many ways I can pick 4 balls out of 12. So if I use my calculator and work that out, I will get 1 out of, and 12C4 is 495, which is that figure there, okay? If I do the same thing now and do the probability of x equaling 1, in other words, selecting 1 blue ball. So of the 4 blue balls, I'm going to pick 1, which means of the 8 blue balls, I'm going to pick 1. Of the 4 red balls, I'm going to pick 3, again over 12C4, which is 8 times 4 over 495, which is our 32 over 395. And we continue that through. The probability of x equaling 2 is equal to, from the 8 balls, I'll pick 2. From the 4 red, I'm going to pick 2. And I now know it's all over 495. So 8C2 is 8 by 7 divided by 2, which is 28 by 6 over 495. And 6 28s are, what's that one? 6 18s are 48, 168, which is 168 over 495. And if I divide them both by 3, that'll cancel down. Right, so if I do the same thing all the way through, I'm going to get these answers here. Okay, now this probability up here, to be honest, isn't a big part of us. This is just how we happen to get the probabilities, okay? It's this table here that's significant for us. So we change our thinking a little bit to what we have done in the past. In the past, our probability, if I ask you to work out, if we had this example, I'd just say the probability that x is equal to 0, 1, 2, 3, or 4, and we work out the probabilities along here, okay? So if you like, what we're doing is we're just adding another row, which we're calling p hat. So instead of us saying we have 0 blue balls, I'm going to say the proportion of blue balls is 0. Instead of saying I've got 1 blue ball, I'm going to say 1 out of 4, one of the 4 balls is blue. So I turn it into a proportion. So you can see there that the proportion is always going to be between 0 and 1. And really, it's just another way of representing how many successes we had. All right. This distribution statistic, which is calculated from a sample, it's called a sampling distribution, okay, because it's come from a sample. All right. So for the sampling distribution above, so clearly let's answer the question. What was the question? What is the probability that there are 2 balls in the sample? So the probability that there being 2 balls in the sample is 56 over 165. Okay, so that's what the likelihood of having a proportion of a half. For the sampling distribution in the above table, calculate the probability that the proportion of blue balls from the sample of size is less than 3/4. So what we're saying is the probability that P hat is less than 3/4, which is the same as then saying the probability of P hat equaling 0 or P hat equaling 1 or P hat equaling 2. Less than 3/4, so it can't be 3. So it's going to be those bottom three, which is 1 on 495 plus 32 on 495 plus 168 on 495, which is 33 plus 168, which is 201 on 495. Okay, so again, up until now, we'd have probably just said, what's the probability of there being less than 3 blue balls in our sample? Okay. All right. What other definitions have we got here? So if we're sampling from a large population, all right, so if in a large population we use a probability that the observed attribute is going to be constant, all right, so we're going to assume that if we've got okay, suppose we know that 30% of all 15-year-olds in Australia own a mobile phone, all right? That is a proportion of people that own a phone is 0.3. Now, if I randomly select one of the students out of that population, and so I've got one less person with a mobile phone in the population, it's not going to change the proportion, all right? Whereas in the previous example, if I took one blue ball out, it was significantly less likely to get another blue ball. When I'm looking at a population or a large population, the probability is constant. So the probability of success is 0.3. All right, we assume the probability is true for all sample size of this population. So if I'm going to choose 6 people, it means that we can say that my sample size of 6 and the probability of success is 0.3. Yeah. So if I use this on my calculator, if I do this on my calculator, it's going to generate all these probabilities for me. So we can see there from the table of values there, we've got our 0.1, probability of 1, 0.303, 2, 0.324, 3.185, 4.05, probably should be 0.060, 5.010, and then finally 0.001. Okay, so because my probability, my proportion P is constant, it's not changing, it becomes a binomial distribution. All right, and so there's our range of values that we could possibly get. Okay. So like everything else, it's got a mean and a standard deviation of our sample. Okay, so if we are selecting a random sample, of n from a large population, again large population, then the mean and standard deviation of the sample proportion P are given by the expected sample proportion is P, okay, and the standard deviation is given by the square root of P times 1 minus P. Okay, so the standard deviation of a sample statistic we refer to as a standard error. So it's terminology, all right? Use the probability distribution from the previous example to calculate the mean and standard deviation of P hat. So what we're saying there is, from the previous example, P is equal to 0.3, and we had 6 trials, which means that the expected value of my sample is equal to 0.3, and the standard deviation of my sample is equal to the square root of 0.3 times 0.7, which is 1 minus P, over 6, which is equal to the square root of 0.21 on 6, which is equal to 0.187. Okay, so there's my standard deviation or standard error, and there's the expected value. Okay, so what we're really saying is I expect my sample to have a proportion of 0.3, and that's the spread or the likelihood of it being out. Yeah. Okay, let's go on to the 17B. Talking about what was we talking about? We were talking about let's go back, Tone.